This video consists of a short overview of the W2SW0011u product offering and its corresponding development kit using the W2SW0011u dongle. The W2SW0011u is based on the Marvell 88W8786 processor. W2Y designers integrated a power amplifier, TCXO, power regulation circuitry, and all required passives in a small 15 by 15 millimeter package. The only components that customers need to add is the circuitry and voltage translator, if needed, for the USB interface, converting 5-volt standard USB levels to 3.3 USB levels, as seen in the block diagram of the W2SW0011u. This enables the customer to eliminate the complexities of the Wi-Fi hardware development with a simple drop-in module, thus allowing the customer to focus on more critical sections of their overall design. 802.11n is traditionally a MIMO technology compared to the older 802.11abg SISO technologies. But what is MIMO versus SISO? This slide provides a high overview of this concept. 802.11abg is traditionally a SISO, single input, single output, or a single transmitter and a single receiver, alternating broadcasting or receiving data. Using old military MIMO concepts, 802.11n was envisioned to operate with a 2x2, 3x3, and 4x4 transmitter-receiver combinations, allowing 802.11n to transmit over the air at 600 megabits with actual throughputs of 2 to 300 megabits. For many low bandwidth applications, 12 to 18 megabits of actual throughput from an 802.11g module operating at 54 megabits over the air, SISO was sufficient. These types of products include digital picture frames, control systems, environmental controls, UAVs, QVGA standard definition display products. As the need for high-definition video in gaming applications have taken the market by storm, the industry found that 54 megabits over the air wasn't enough. Thus, 802.11n MIMO seemed to be the perfect solution. Companies began deploying enterprise-wide access points with 802.11n 4x4 MIMO configurations. There was one major drawback with a 4x4 MIMO configuration. It draws between 1 to 2.5 amps of current. This is fine for a wall-powered unit, like an enterprise deploy access point, but for the mobile or battery-powered markets, this would be a death knell to the technology. So many companies came up with the idea, about the same time, to use 802.11n in a SISO or a 1x1 configuration. Operating at 64 QAM with a 40 MHz channel with a 400 nanosecond guard interval, 150 megabits over the air is possible. This equates to an actual throughput of 30 to 40 megabits. This, along with MPEG-4, H.2.64 encoding, enables HD video to be transmitted over the air. More importantly, the current consumption drops to 210 milliamps, the same level of current consumption as traditional 802.11a/bg SISO solutions. The W2SW0011u is easy to use and implement. The following brief overview of the Quick Start Guide is a testament to that reality. The contents of the development kit are as follows: a W2SW0011u dongle. As you can see from the picture, the dongle consists of a standard USB connector, the 802.11n module with an onboard patch antenna, as well as the ability to configure via resistors R5 and R6, an external Hiroshi connector for use with an external antenna. A CD is provided with the Linux binary drivers and firmware for the W2SW0011u dongle. The Linux wireless tools, which need to be installed for Linux to control the wireless interface, are included as well as binaries of the open source program called iPerf, which is useful for performing throughput tests. The Quick Start Guide takes you through installing the drivers on both an Intel-based Linux laptop as well as a PXA 320-based development platform. Now we'll cycle through some of the pages for you to see. Here, of course, again is a photo of the W2SW0011u dongle with some instructions on how to set up the driver. We try to put detailed images step by step to show you what it'll look like as you try to install on your Linux system. It's quite easy, as you can see, to install the driver. We've also included some instructions on iPerf and how to set up iPerf between a client system as well as a host system to do throughput testing. We've also included a setup instruction guide for setting up a Kirkwood or a PXA 320 development kit platform. With the driver installed and the dongle plugged in, you are on your way to developing your dream product. I hope this introduction was helpful. Please make sure to contact Y2Y Sales for any other questions. And your FAEs, Arun Kumar on the West Coast, as well as Will Lumpkins on the East Coast, will be more than happy to help you. Thank you again.